We know from experience that liquid water will spontaneously evaporate to form gaseous water, even though the process has got a huge activation barrier. It's very endothermic. It has a heat of vaporization that is positive 40.7 kilojoules per mole. So the question is, what is providing the uphill driving force? And the thing that is doing this is a term called entropy. Entropy is defined as being a measure of the disorder or randomness of the particles that make up a system. Water will spontaneously evaporate at room temperature because it increases, or it allows the amount of disorder in the particles to increase. If your entropy, and the symbol for entropy is S, of the products is bigger than the entropy of the reactants, your change in entropy is going to be positive. So if it's positive, that means it's becoming more random. So looking at these two examples, in the first one we have two gases becoming one gas, and so it is becoming less random, and so our delta S in this case is going to be negative. In the other example, we have a pure substance going to one that is mixed with water. So in this case, the system is becoming more random, so our delta S is going to be positive, or bigger than 0. So let's look at another example, so we can decide whether all positive delta S reactions are spontaneous or not. So for example, here we have liquid water going to form gaseous hydrogen and gaseous oxygen. We have a very large and positive delta S, but we know that liquid water does not spontaneously break down into hydrogen and oxygen gas, which is a good thing because that would be flammable. So in this case, delta H is large and positive as well. The thing that allows us to go back and forth between whether the change in entropy and the change in enthalpy, or delta H, is Gibbs free energy, another delta. And so Gibbs free energy allows us to predict the spontaneity of a reaction. So Gibbs free energy, the equation is delta G is equal to delta H, the heat of the reaction, minus temperature in Kelvin times delta S. If you end up with a negative delta G value, it was a spontaneous reaction. The reaction actually occurs. So here is one of the practice problems, the first one. And so it gives you a reaction, and then you have to calculate first the delta H for the reaction, and then you have to calculate the delta S for the reaction, and then finally figure out what the delta G is going to be, so you can find out whether it's a spontaneous reaction or not. So first, looking at the delta H, whenever you're doing these calculations, it's always going to be products minus reactants. So you just fill in the numbers. So delta H is equal to, we have 2 waters, and we're going to subtract off our 2 hydrogens and our 1 oxygen molecule. So filling in the numbers, so we have 2 times the delta H value for water, which is minus 285.83, minus 2 times 0, which is a delta H for hydrogen, plus 1 times 0, which is a delta H formation for oxygen. So you run that through the calculator, and we get a value of negative 571.66 kilojoules. It's important to make note of the value for the units. Next, we're going to do the same thing for delta S. So delta S is also products minus reactants. So looking at the values, we have our 2 waters, again, minus the 2H2 plus the 1 O2. Fill in the numbers. Delta S is equal to 2 times water's value, which is 69.95, minus 2 times hydrogen's value, which is 130.68. Oops. 2 times 130.68 plus oxygen's value, which is 205.152. You do the calculations, and you get that your delta S value is minus 326.612 joules per mole Kelvin. Alright, so just writing these down again, delta H is minus 571.66 kilojoules. Delta S is minus 326 joules per mole Kelvin. Your units have to be the same, otherwise you're going to be doing an apple and oranges kind of thing. So in order to convert our joules into kilojoules, we're going to divide that value by 1,000. So it's equal to negative 0.326 kilojoules per mole Kelvin. Now that we have all of this stuff, the numbers prepared and ready to go, and if you look at the problem, it tells you that your temperature is 298 Kelvin for all of these. So delta G is equal to delta H minus temperature times delta S. So delta G is equal to our minus 571.66 minus temperature 298 times our delta S, which is negative 0.326. Punch that into the calculator, and you get a final value of minus 474.33 kilojoules. Because this value is negative, it tells you that this is a spontaneous reaction. It actually occurs the way it's been written. If it were positive, it would tell you that actually the reverse reaction is the one that happens, not the one that you wrote down on the paper.